All right, this is the Desmos on the transformation to exponents to exponential and logarithmic graphs. So the warm up was to solve this equation. So you have to put the same base here. So base 2 would be the base, so 2 squared, and then times 4x in the exponent, and then 8 is 2 cubed, and then x plus 2. You see, so now you can equate the exponents here. 2 times 4x equals 3 times x plus 2. We go ahead and put a semicolon in here between the steps. Then you have 8x equal 3x plus 6 when you do the distributive property. And then subtract 3x. 5x equals 6. And then finally, x is equal to 6/5. And then this is a refresher about the transformation. So the a value, if I click on the a value, let's reset all this because it's confusing the way it is now with the dash graph. Okay, so now let's reset here. A value, when I increase the a value, that causes dilation with the respect to the x-axis, or vertical dilation. So we'll name it, and if a is negative, and it causes a reflection across the x-axis, or a vertical reflection. Let's go ahead and reset again, and then the b value also causes dilation with respect to the y-axis, or horizontal dilation. And then b is negative, cause reflection over the y-axis. And then c, that's just left or right. And then d is up and down. So this is already filled in. A causes dilation with respect to x-axis, or we can call that vertical. When an a is negative, it's exponential decay, or reflects over the x-axis. And in slide 6, that's called vertical reflection. And b cause dilation with respect to y-axis, or horizontal dilation. Reflect over the y-axis would be horizontal. reflection. So the reason why I'm doing it different ways here, because the vocabulary on slide 6 says these things: vertical reflection, horizontal reflection, vertical dilation, horizontal dilation. And then C causes translation left or right, and D causes translation up or down. So the same thing here. Let's reset this to the original. And then A is dilation with respect to x-axis, or vertical dilation. A is negative, reflected over the x-axis, or vertical reflection. So reset that. And then B is dilation with respect to y, or horizontal dilation. If B is negative, it's reflected over the y-axis, or horizontal reflection. We're going to reset everything. And then C is left or right. D is up and down. So we can add here vertical dilation. So A causes dilation with respect to x-axis, or a vertical dilation. When A is negative, causes reflection over the x-axis, or vertical reflection. B causes a dilation with respect to y-axis, or horizontal dilation. And when B is negative, it causes a reflection over the y-axis, or horizontal reflection. And then C translates the graph left or right, and D translates the graph up or down. And then to match these up here, so if I move these equations on either side of the screen here, whoops. So let's move the equations over here. And on the other side here. All right, these are all log graphs. So horizontal dilation of 5 and left 1. That goes with this one here. And then vertical dilation of 5 and horizontal reflection left. Those 3 things here: vertical dilation of 5, horizontal reflection, and left 2. So that's this one. Whoops. Reduce that. And then vertical dilation of 1/5, horizontal dilation of 6. That's this one here. Vertical reflection and right 3. That's this one. Vertical reflection, so negative, horizontal dilation of 5 and up 2. What goes here? So vertical dilation on 1/2, horizontal reflected, and down 5. It's this one. Vertical reflection, horizontal dilation of 1/2, and right 5 goes here. And then the last one, you X this out here. All right, this goes with this one. And let's make this bigger now. So, whoop. Okay, and then you show the answer key here. They all light up green, so I know I have the right ones. As long as the person who did the answer key did it correctly. Looks like they did, so. All right, so this one, the negative in front of the 2 reflects the graph over the x-axis, or that would be a vertical reflection. The -1, and the exponent translates the graph right 1 unit. The +3 translates the graph up 3 units. The domain for this red graph, -infinity to +infinity. The range is -infinity to 3. The asymptote y equal 3 is decreasing along the domain there, -infinity, +infinity, and it's not. It's never increasing. In number 8, the +3 translates the graph 3 units to the left, and -2 translates the graph down 2 units. The domain, so here's my vertical asymptote, -3 to infinity, so all log graphs have a vertical asymptote. The range for any log graph is all real numbers, or -infinity to +infinity. The asymptote x equal -3, decreasing, not atypical, increasing from -3 to infinity. So this one, let's reset. It looks like we want to move the graph over here. So 4 is the asymptote. So if we do this, x minus 4. So you want to try to pass the graph through the stars exactly, so that works. And then 10, let's reset this here. So it looks like we want the asymptote to be right here. So if I put a +2 in there, and then we want to move it down. So there we go. +2 in the parentheses makes this the asymptote, and then -5 moves it down 5. Number 11, let's reset that. So we want to do a reflection here. So it's a negative. And that reflects the graph over the x-axis, or a vertical reflection. Let's reset this one. This one we want to do a horizontal reflection or reflect over the Y. So I should put a negative there. Let's reset this one. So it looks like I want to be the asymptote as to be -3, and I want to do log. And then base 2 is if you hit the shift and then the key next to 0, give me a subscript. So log base 2. Then hit the cursor to the right. Oh, if I just put X in there, that's the original graph, the parent graph. And then if I put +2 or +3, I want the asymptote to be at -3. And that's enough to translate the graph to the correct position. Let's reset this one. So you want to do log base 2 again, log _2, and there's log base 2 of X. Looks like I want the asymptote to be at 2 there, so all right, X -2, and then let's try to move it up a little bit. So +1, that works. And then 15, you want log base 2 again, log _2. Right, there's what the graph looks like. It looks like I want to have the asymptote at -4 or so. So let's do +4. And then we want to flip it. So minus there, that works. So the negative is a vertical reflection or a reflection about the X. And X +4 makes the asymptote to be -4 there. And the last one, you want log base 2 again. So log _2. There's the original, log base 2 of X. It looks like we want the asymptote to be -1, so +1. And then move it up. So it's like try +4. Yep. All right, so that's the video of the transformation of exponential log graphs.